Hi, I am Enayat Rejabi from University of Alcalá in Spain. This presentation is about exposing any kind of data as linked open data and interlinking between data sets. I will explain about the linked data principle, semantic web a little bit, and I will describe how we can expose the data as linked open data. And I also explain about the interlinking, how we can link two data sets together, and I will conclude with some highlights of this presentation. As you know, semantic web allows data publishers to publish their data in RDF format, in a structured format, and afterwards it allows to create links between the RDF. So finally, you will have some RDF, let's say, data sets, and then these data sets can be linked together. So we are using this technology to first create a structured data and then link the data and data sets together. As you can see in the left side, this is the architecture of the semantic web, and in the right side you have linked data. So linked data technology is a part of semantic web. So when you create RDF triples, you are using linked data principles, and you can create a Sparkle endpoint, a query interface to allow other data sets to query your data as well. But what are the benefits of linked data? Briefly, linked data approach allows you to integrate and interlink distributed data together by using some linking approach. It allows other uh, data sets to query and to discover your data on the web. And it also leads to enrichment. It means that if your data are connected to useful knowledge on the web, then your data are enriched by more information um, or more knowledge on the web, because your data is connected to new data on the web. According to the linked data principles, which mentioned by Tim Berners-Lee in 2007, each element of your data should have a URI, and this URI should be discoverable through HTTP protocol on the web. And when the other users look up your data through this protocol, they should retrieve useful information on your data store, let's say. Also, your data should be linked to other datasets using some RDF links. So, using these RDF links, your data should be connected to other datasets, and other datasets can be connected to your data as well. This is four principles that we should take care of these principles during converting our data to linked data formats. So what are the RDF triples? So this is a structure. It is let's say the format that we can use for structuring our data in the shape of linked data. So if you have a document, this document can be represented in let's say two triples. First, this document has a term, let's say music. So each element or each information and data should be represented in triples: subject, object, and predicate. Here, uh, let's say here the subject is document, your document, and the predicate is term, and the object is music. It's the same for author. This document is created by Fabian, so Fabian should be the object, and the subject is your document, and the relationship between the subject and the object is a predicate, so it's author. There are many kinds of linked data exposure that you can follow to expose, to publish your data as linked data. In the first level, as you can see, you have different kinds of data, non-structured and semi-structured. Maybe your data is an Excel file or an XML file. So this data should be converted to a structured format, let's say RDFI data. In this step, all data are the shape of RDF, and then this RDF data should be imported into a RDF store or triple stores, and finally some services, mashups, or some interface or search engines are created on top of these data stores, and your data will be available through this interface for other data sets. So how we can expose our data as a linked data format? As you can see here, we have several steps to expose data as linked data. First, we should select the proper schema or ontology for our data. Maybe, for example, we can use some flat schema like Dublin Core for exposing our data as linked data. But sometimes our schema needs some ontology, let's say, for exposing. For those complex, let's say, schema, we have to create a new ontology, and then we should start mapping our data according to the ontology to the linked data formats. So when we have the final schema and the ontology, then we convert our semi-structural data to a structured format, to RTF, and we create RDF dumps, let's say, uh, a set of RDF triples, and according to the ontology that we created. So here in the third step, we have the RDF dump that we created according to the schema and ontology that we had in our mind. And finally, we can import the RDF triples to a triple store or data store. So finally, we can set up a Sparkle endpoint on top of that, and our data will be available through a query interface for other data sets as well. But as I mentioned, you can expose your data to a flat schema like Dublin Core. If your data are available in some relational tables, you can retrieve your data using some joins or in one table, and you can map one element to one element to a flat schema. For example, you can say, okay, this is my book title, and this book title can be mapped to title in this term, let's say, vocabulary, or this date can be exposed as a Dublin core. And this is very straightforward approach and very simple, so you can use some flat metadata. You don't need any ontology in this step. But when your data is a little bit complex and the schema includes some hierarchical level, so you have to use some ontologies or let's say classes in your schema to describe your data in a proper way. So you have to define some semantics, let's say, in your data as well. So here you have RDFS as a first level. So you provide some um, primitives ontology and primitive classes in your data. You can say, okay, there are the relationship between the elements of my data. So do you define classes in your sources, and you can define the relationships between the objects in your data. For example, you can say, for example, person is a subclass of the man, male subclass is the man, and there are some relationship between the classes. And let's say RDFS is a simple format of ontologies. So you define some classes, subclasses, and relationship between the elements in your data. After defining this, let's say, schema, after defining these classes in your data, then you can reuse some vocabularies. So you don't need to create, let's say, create new vocabularies or new schema for each element. Sometimes you can use or reuse vocabularies in your data. For example, if you have the title of the book, you don't need to create, for example, your schema title. No, you have the doubling or you have scores and other vocabularies that you can reuse. So try not to create new vocabularies when you have some well-known, let's say, vocabularies as well. So, for example, doubling core, Creative Commons, for scopes, there are some well-known, let's say, vocabularies that you can use. For example, here, for example, defining the labels or title of your objects, you can use scopes. Scopes allows you to define, for example, preferable label for your objects or alternative labels in your objects. Or you can define some, let's say, relationship, very simple relationship between your data items. You can define some broader, narrower, and related relationships. So in this way, you can define a hierarchical, let's say, relationship between two data items in your data. So using scores is a good approach for defining um, your data and their relationship to each other. When you have your data and a schema, then for your whole data set you can define some descriptions. This is not for the data items, but for whole data sets. For example, there are some vocabularies like void that you can describe that, okay, this is my data set. The data set is for created by which person, for which organization, how many triples it has, for example, what kind of relationships, how many relationships exist in my data set. And this is, let's say, metadata about your data sets. There are also some linked data exposure tools that you can use for exposing your data as linked data. For example, if your data exists in some tables, relational tables, you can define some rules, let's say, to uh, map or expose your data in a triples and linked data format. You can say, okay, I have name in this table and this name is the same as, for example, name in fourth, or it is a title of my book. It can be title of the book. And this kind of relationship can be defined in some tools, and they can provide such services for you. For example, D2RQ is one of the services that you can use. D2RQ has a mapping file. So in the mapping file, you can say, if you get this, for example, information from database, so you can map this information from tables to linked data formats and to these vocabularies as well. And finally, D2RQ sets up the Sparkle endpoint on top of the RDF, let's say, dump, and they can, the other data sets, they query your database on the fly. So When you update your database, your information in RTF format is available for other data as well. The good point for D2RQ is this updating approach. So your data, when are added to the database, other data sets can retrieve new data or read most recent data in RDF format. But the negative point of our D2RQ is a performance issue. It means that when you have your data in the database, in non-RDF database, each time you get a query, this information should be mapped on the fly to the RDF. So it takes time to get the results of the query. So when you have your structured format, you should create RDF dump. Let's say a text file format or a triple, let's say, file. That's a big file that you should create to be imported in a triple stores. You can use it, you can create this RDF dump using a tool, let's say D2RQ. According to the rules that I mentioned, you can say that, okay, I need this data from these tables, and then you can create a big RDF dump using these tools. But if you don't want to use such tools, you can write programs using some Java libraries like Jenna, and then you can define the ontology that you want to your data uh, be exposed according to that ontology, read data from some tables or something like that, and finally you create a RDF dump according to the model that you want. So you have two approaches for the creating RDF dump. When you have the big file and RDF dump, you can set up a Sparkle endpoint, load your data in a triple store. It depends on the size of the RTF dump, but you can use a wide variety of triple stores. For example, Foseki, Virtuoso, even D2RQ. So you can use this kind of triple stores for as a data source of your RTF dump. For example, DBpedia uses Virtuoso. For example, in some projects, we used Jenna Fuseki for loading RTF dumps in a triple stores. And afterwards, you can use some Fuseki, for example, commands to load the data in a triple store and setting up a Sparkle endpoint on top of that. So to have a summary about exposing data, I should highlight that first you should define your schema. You should specify that your metadata or data is a flat or hierarchical. Does your data use some vocabulary, control vocabularies or not? You can use some tools to convert your data to a structured format. For example, from relational database to RDF, there are some tools that allows you to map your data. And or you can do it by some programming languages like Java. And when you had your ontology or reuse vocabularies, you can use some mapping tools, or you can write a program to convert your data to RDF dump and create your RDF dump according to the ontology or schema that you would like to have. And finally, you can import your RDF dump in a triple stores, and you can set up a Sparkle endpoint on top of your data store. As a case study, we created an ontology for IEEE LUM schema. IEEE LUM is a metadata schema for describing e-learning objects. So To expose the IEEE alarm elements as linked open data, we had to create ontology because IEEE alarm had some elements in a hierarchical shape. Let's say, for example, IEEE alarm use some classification. And in these classification, the elements are represented in a hierarchical level. So we had to create an ontology for IEEE alarm, and we use this ontology in several implementations, in organic Ethernet, in Open Discovery Space projects, and the information available there. So this is, for example, in organic Ethernet, we use this infrastructure to expose the data as linked open data. As you can see here, first we harvested the metadata elements and converted the data to a relational database. When we have the data in a relational database, we converted or mapped this information to RDF using D2RQ services. In the D2RQ service, we set up a mapping file, and we specify which elements or which data we want to expose, and D2RQ expose this information in a triples and set up a sparkle endpoint on top of that, and we use some interlinking approach to link the final RDF data to some data sets in the LOD cloud. So the next topic is interlinking. Interlinking allows you to create links between the data sets. The data by this approach can be discoverable and can be searched by other data sets on the web. You can create links by different kinds of relationships, like old, same as, and other kinds of relationships. And data publishers, they can use some tools, some software to interconnect their resources to useful knowledge and information on the web. So as I mentioned, one of the aim of linked data and the interlinking is enrichment of data. So if you have some data here and you have some text and you want to clarify this text or link these resources to some informative data sets on the web, you can create links and you can, let's say, enrich the titles or description of your data in your website. Interlinking approach can be pictured in this image that you can see. For example, this is the infrastructure of the interlinking tools. They use some matching algorithms to find similarity between two data sets. You have a data set, for example, your data set in the left side, your target data set in the right side, and you specify some conditions and some filtering because you don't want to map whole data sets to another data set. You want to interlink part of your data sets to the final data set as well. So use some filtering and conditions to filter out those records that you don't want. Finally, after specifying this condition, you give this information to interlinking tools, and these tools they can discover the similarity between two data sets, and finally they get the result in, for example, 2 or 3 columns. For example, say the left side, say this term is the same as this link on the right side. And this result can be reviewed and revised by the human experts, and they can say that, okay, the result is good or not, or can be analyzed by some systems or some programming language. You can analyze your data afterwards. So this is a whole workflow that interlinking tools follow. The general configuration that you may specify in the interlinking tool is as follows. You have a source dataset, target datasets. In the source dataset, you should specify the URL of the RDF dumps or Sparkle endpoint so that the interlinking tool can get query using this URL. And you should specify the title or the entity that you want to link with the target datasets and some filterings. For example, you can filter the entities according to their language or some other specification that you want to put it in the in your source entity. And your target entity or target dataset, the story is the same. You should specify a Sparkle endpoint or RDF dump if you have from the target dataset and the entity that you want to interlink to, and the filtering that you want to put on the right side or right datasets. And there are some conditions. You can specify the matching algorithms between two the text or strings, and you can specify a threshold. For example, when you say 90% similarity between two terms, it means that if two terms or two strings has more than 97, 95, let's say, similarity, the interlinking tool should consider these two strings as a matched terms or matched entities as well. And the other specification like what is the output format and something like that. So after specifying the source and target configurations and with some conditions, the interlinking tool uh, get the results according to the configuration that you mentioned. In a study, we consider several interlinking tools according to some criteria, like the domain that they use, the type of data that they get for interlinking, and they do the interlinking manually or automatically. What about their documents? Is their are they, let's say, well documented or not? How and to what extent the interlinking tool are customized, and are they flexible in the customization or not? So according to these criteria, we considered and compared uh, 7 interlinking tools, and finally we used and we selected Limes, LOD, Define, and Silk for our studies, and we realized that, for example, among these tools, Sync and Limes were more reliable in terms of getting more results and precise result as well. This is the screenshot of the Silk Workbench. Silk interlinking tool has two versions, Workbench on the web-based, let's say, and the CLI. So in the web-based, you can use some drag and drop techniques, and you can do the interlinking in a web-based format. And, as I mentioned, Silk has a command line version, so you can specify your information and configuration in XML files, and then you can run the tool as well. Limes has also XML files for configuration. You can specify your source data, your target data, the conditions and filtering for each data source, and specifying the algorithm that you want to use for interlinking and some thresholds, and the final file that includes the result of interlinking. This is a LOD Refine. LOD Refine is, let's say, a tool for general cases. You can refine, you can clean the metadata, and finally you can use some reconciling services for performing the interlinking between two data sets. In the LOD refine, if you want to go through this tool, you can import some data. For example, we imported 10 country here into the tool, and we can add some reconciliation services by defining RTF dump or sparkle endpoint, and you can define your RTF dump here. You can specify in which entity of your target dataset you want to interlink, or you can use some Sparkle endpoint and URL here by specifying its URL, the graphs that you want to interlink, and the entities that you want to link your data source to them. After defining that, so you have the data, then you can, on the column that you want to interlink, you can click and you can use the reconcile services, and you can start the reconcile. When you start the reconciling service, you can use the target data set that you want to interlink, and after it takes time. It depends on the size of the data that you have, for example, and the target data set that you want to interlink. For example, if you have 10 data and your target data set is small, so the whole interlinking should not take time. But if you have, let's say, thousands or billions of data, and you want to interlink to a big data set like DBpedia, it takes time. Maybe, I don't know, maybe it depends to the equipment that you have, but maybe you should leave your computer for some days. And finally, the interlinking result is something like this. So it says that, for example, this country is connected to this URL in the datasets, and you can get the matched results, and those records that were not matched to the target datasets. And you can have some actions for your interlinking results. For example, you can reconcile or do the interlinking to the interlinking again from the beginning, or you can discard the reconciliation judgment. You can change the judgment as well, or you can add some columns. For example, if you want to get the URL, the specific URL that the interlinking tool found, you can add a column, for example, in your area, and other specification that you have. For example, we added the URL, so you can see this column that has been added on the right side. As I mentioned, you can change the scores, you can change the judgment, and you can see the results, to what extent the result changed. This is another case study. As you can see, one term, the left side, has been linked to several terms on the right side, but with different scores. As you can see, this, for example, word can be connected to 3 links on the right side, but it's up to you to choose the correct term that you want to have on the right side. So according to the scores or the type of data or the concept of your data, you can define, or you can specify those results that are more related to your data sets. For the limas, the story is different. So you should specify this information in XML files. You should define the endpoint and the filtering. For example, here in the left side, we have a Sparkle endpoint. We want to interlink these data sets and their titles only. And those titles should be considered in a lowercase to the target data set, which is an open discovery space Sparkle endpoint. And we want to interlink title of this data set to title of this data set as well. We want to use Levenstein-Stans algorithm for finding similarity between titles, and we want to use the threshold. The threshold is 90%. It means that if two titles have more than 90% similarity, the tool should consider these two strings as matched. And this is some information about the target file result, and you have another file as well. So this is the matched records, but the tool can get the results for those records that have more than 50% similarity. So there are, let's say, less precise results, and this is more matched result that you have in two different files. And after running the interlinking tools, the limas, with some job of comments, so you will have the results in a log file, and you can get the results, something like that, in two columns, the source link and the target links, and you can consider, or you can um, compare the results and evaluate it one by one. As a conclusion, I explained that how we can expose different kind of data as linked open data and as RDF, and how we can use the ontologies for exposing data. I also explained how we can interlink two datasets, and after getting results of the interlinking, we should revise the results by human expert to filter out those results that are not applicable for our purpose. And finally, we should use and we should ingest these linked resource and result in our data set, because it's very important. And finally, we should integrate these results to our data set as well. And with this kind of ingestion, our resources can be enriched by useful information on the web with the linked resources. This was my presentation, and I hope you like it.